Hello everyone, I hope you're all doing well. In this video, we will discuss few common questions which are commonly asked in our uh, examination from the states of matter. So starting with this first question, in which they are asking that sulfur has boiling point of 445 degrees centigrade and melting point of it is 115 degrees centigrade. Predict the physical state of sulfur at 210 degrees centigrade. So as you can see that its boiling point is 445 and its melting point is 115 degrees centigrade. So let's suppose if it is at 0 degrees centigrade and you have started heating this solid sulfur, and at 115 degrees centigrade it will melt, and at 445 degrees centigrade it will boil, right? So this temperature, they're asking that what would be the state of the sulfur at 210 degrees centigrade. So 210 degrees centigrade lies between the melting point and the boiling point of this sulfur. So at 115 degrees centigrade, if this is the melting point of sulfur, it means that it is now converted into liquid state. So from 115 to 445 degrees centigrade, up till 450 degrees centigrade it will remain in the liquid state, and at 445 degrees centigrade it will convert into gas. So it's mean that at 210 degrees centigrade the physical state of sulfur would be liquid. And what is its explanation? That this temperature 210 degrees centigrade is more than the melting point and less than the boiling point of this element, right? So this is how we can explain. Then the diagram shows a heating curve for a sample of compound X. So we have this heating curve, and this heating curve is for an unknown element. So is X a solid, a liquid, or a gas at temperature 20 degrees centigrade? So as you can see that this slope shows that the temperature was rising, and at this moment there is change in state. So and there is another change in state. So probably and definitely it would be solid at this point, then liquid at this point, and then gas at this point. And at 20 degrees centigrade, like it was solid and then it is converted into liquid state at 15 degrees centigrade. This would be its melting point. So this is the point where solid will convert into liquid. So what would be its state at 20 degrees centigrade? What do you think? Liquid, right? 15 degree 20 degrees centigrade is the temperature where it will be. Maybe it is here 20 degrees centigrade. It will be in liquid state at this temperature. And name the change of state that which occurs in the region D to E. So at this point liquid is converted into gas. So at this point, what is the conversion? Liquid into state. The process of this conversion is called boiling. So this is boiling. So this is boiling. And then write an equation for the equilibrium which exists in region D and E. What is equilibrium? Equilibrium is something where the forward reaction and reverse reaction, forward process and reverse process are equal. You can memorize it by using its name, equilibrium. So there is conversion that liquid is, during boiling, liquid will convert into gas, and that gas can convert back into liquid state, right? So if this process, this forward process and this reverse process, if both are equal, that state is called equilibrium. So you can simply write that there are these two states which are in equilibrium state at this point. And similarly, if you want to write at what would be the state at this point, so solid is converting into liquid. So solid and liquid both states are present at equilibrium on this point. That is why I have explained in my first video about states of matter that the freezing point and melting point of any substance are same. If water will water will melt at 0 degree centigrade, it will also freeze at 0 degree centigrade, because at 0 degree centigrade, at the melting point, the solid and liquid are at equilibrium. Both of these processes, conversion of solid to liquid and liquid to solid, are happening at the same rate, at the same speed. So the melting point and the freezing point both are the temperature are same. And if you will raise the temperature at this point, then solid definitely it will convert into liquid state because of the high kinetic energy, and if you will lower the temperature, the liquid will convert into solid state if you will lower the temperature. So this is this temperature melting point or freezing point, where at this specific fixed temperature both states are present and on equilibrium. Like at 100 degrees centigrade, on 100 degrees centigrade, the water molecule in liquid state and gas state will exist at equilibrium. So in boiling at that specific temperature 100 degrees centigrade, both of these states will remain at equilibrium. If you will change the temperature, if you increase or decrease it, then there will be only one state present. If you will increase temperature of water above 100 degrees centigrade, then the water will convert into gas state. If you lower it, the water will turn back into its liquid state. So this is how the state of equilibrium lies between those two states in these conversion points, in these melting point and boiling point. So you can write this conversion by using these two arrows. Then explain how the curve shows that a pure sample of X was used. So you can simply say that because this temperature, this is a fixed temperature, so anything which is pure will always have a fixed temperature. If it is impure, then it can boil or melt at a range of temperature. So if it is melting at a very sharp 15 degrees centigrade, it means that it is a pure substance. Like it is boiling at 80 degrees centigrade, very sharp 80 degrees centigrade, it means that it is instantly converted into gas when the temperature will reach 80 degrees centigrade. That means that it is a pure substance. So pure substance will melt or boil or freeze or condense at a very sharp fixed temperature. So this curve shows that this is a pure substance, right? Then what are the processes W, X, Y and Z in the following diagram? Very easy. Solid will convert into liquid. What we will call this process, conversion of solid into liquid, is called melting. Then liquid into gas, what is the process? X, it is boiling. Then solid into liquid, Y, or sorry, liquid into solid, this is Y, so freezing. And gas into liquid, this is condensation. So the option C is correct one. Then the diagram shows a kettle of boiling water, and as the water vapor cools, it turns into droplet of liquid water. Like it will basically, it's a very simple term, condensation. So conversion of gas into liquid is called condensation. So the change of state when water vapor changes into liquid water is described as this process. Then 4 statements about the arrangement of particles are given. Read it. You can pause this video and just try to answer this question. Okay, so 4 statements about the arrangement of particles are given. Particles are packed in regular arrangement. Okay, particles are randomly arranged, like liquid particles or gas particles. Particles move over each other, this is for liquid particles can move over each other. And particles vibrate about fixed point. At which state particles can only vibrate about fixed point? That was solid, right? So which statements describe the particles in a solid? So as you can see that this first statement, particles are packed in regular arrangement, so it is correct for solid. Particles are randomly moving, that is not correct. Particles move over each other, it's not possible in the case of solid. Particles vibrate about fixed point, it is also correct. So the option, so the 1 and 4 both are correct, so the option B is the right answer. Then describe the change in the arrangement, movement and energy of particles when the liquid wax cools to solid. Like liquid is converting to solid, which process is this one? That liquid is converting to solid, it is freezing. It is freezing. So how we can write the change in arrangement? So when liquid will convert into solid, what type of arrangement, change in arrangement will occur? It will become regular arrangement. Then movement of particles will move slower, and energy of particles, it will the lower energy of particles at a solid state. So this is how you can just write it in the form of statement, and then that will be enough for your answer. Now describe the arrangement and motion of molecules in a gas. Gas molecules are randomly arranged. We know that molecules of gas can collide with each other, they are far away, so they can randomly arrange. And the motion, what type of motion these can have? Free random motion. So particles of gas can have free random motion. Now which row represents the particle of gas colliding most frequently? What do you think? Like most colliding collision is like when particles will strike with each other most frequently. So when you will apply pressure on a gas container, then particles will come closer to each other. At high pressure, particles will come closer to each other, and as there will be lesser distance between them, these will collide more frequently. Like more number of collisions per minute will occur, let's suppose. So at high pressure, particles will collide more. And temperature, when we will increase temperature, what do you think that particles are going to collide more or less? Definitely particles will collide more, because as you will increase temperature, the kinetic energy will increase, they will move faster, and that's why there will be more number of collisions per unit time. So that is why at high temperature, high pressure, particles of gas will collide more frequently. Then pure water boils at 100 degrees centigrade. What happens to the water particles when water boil? Right, so when water boils, the particles will gain energy, right? The particles, we are providing heat, that heat will convert into kinetic energy, so particles are gaining energy. And when they will gain energy, the particles will detach from each other, their energy will overcome the forces of friction between them, so they will detach and they will move apart. So this first statement is correct, right? And then this question where we have two gases, they will join together, and we just have to know that which one will diffuse faster. We have already done this one in our previous video, you can watch that, or you can try to solve this question. Otherwise you can comment in the comment box, and then we can also discuss this question in our comment box. Then the last question. A crystal of purple potassium magnate, this is a compound, was added to each of the beaker shown in the diagram. There are two beakers. One of them is containing hot water and the other one is containing cold water. So one beaker contained hot water and the other one contained cold water. In both beakers, the purple color of the potassium magnate spread out. Which result and explanation are correct? Right, so color spreads faster in cold water. We have learned that diffusion will increase, rate of diffusion it will increase if you will increase temperature, or if the molecular mass of that substance will be lower, right? There were two factors which can affect on the rate of diffusion: temperature and molecular mass. So right now we are discussing temperature, and we have learned that if you will increase temperature, molecules will diffuse faster because of their kinetic energy. Their kinetic energy will increase, they will strike with each other, and they will move apart, like they will move from higher to lower concentration in a faster way. So colors spread faster in hot water because the temperature is increased. So the answer could be C or D. Particles move faster at a high temperature, particles move slower at a high temperature. So it is very straightforward answer. Particles will move faster at high temperatures. The answer C is the correct one. So these are few questions, commonly asked questions from our past papers. You can also solve more questions for better clarification, right? Okay, thank you so much.